Assalamualaikum warahmatullahi wabarakatuh. We are from Group 4. We will be doing a revolutionizing in construction, and our topic is 3D printing to build a replica house. In our poster is contained problem statement, product description, useful and benefit of the subject, and lastly is conclusion. First, let me introduce our group members. We have Anisa, Solihin, Aiman, Hazi, Najmi, Fasha, and lastly is Shuhada.
Assalamualaikum warahmatullahi wabarakatuh. Now I want to present about introduction. So, within the rapidly changing realm of modern technology, 3D printing has surfaced as one of the groundbreaking discoveries with the capacity to revolutionize a multitude of sectors. The building business is one of those that is going through revolutionary change extremely swiftly. The growing amazing capabilities of 3D printing are currently challenging traditional construction process and offering a faster, more more economical, more accessible and sustainable building option for all stakeholders engaged in the construction sector. The entire international community may envision a very great advancement where house can be created with incredible speed and precision using a fraction of the resources required by conventional method. And then the faster 3D printing can advance the construction sector. With the introduction of 3D printing technology to the construction industry, this vision come to pass. Using a digital model as a guide, 3D printing, sometimes referred to as additive manufacturing, that is the process of creating an object layer by layer. Despite the fact that 3D printing is a relatively new technology and has been around for decades, it has exhibit unprecedented pace in the building industry. 3D printing is especially changing the game in the replica house building industry. There is a ton of potential for architects, engineers, and home owners when it comes to replicating old homes with remarkable accuracy and efficiency. A digital blueprint is created by scanning an existing structure, and this blueprint is then fed into a 3D printer. So the printer meticulously construct the scan copy of the house layer by layer, catching every minute of the feature. That's all from me. Thank you.
Next is objective. The first objective is cost effectiveness is one of the goal of building a replica house with the 3D printing. House is being constructed. The construction process can be more efficiently run by utilizing 3D printing technology. Second is time efficiency. Construction can process more quickly than with conventional technique to the continuous operation of 3D printer. The second is the ultimate goal is to customization and design freedom. The capacity of 3D printing to produce intricate and bespoke design to one of its primary benefit. Complete range of customization and design freedom can be achieved while construction a 3D printing replica home.
Now, I would like to talk about the problem statements. The first problem statement is limited means of visualization. The pre-3D printing era grappled with a dearth of sophisticated visualization tools. Two-dimensional blueprints and traditional models lacking the capacity to offer an accurate and immersive representation of the final product emerged as a stumbling blocks in effective communication. Stakeholders found themselves navigating a landscape characterized by pervasive misunderstanding, disrupting the collaborative design process. The absence of three-dimensional vision aids created a communication gap that directly impacted the accuracy of the final construction. The second one is skill manual craftsmanship. The replication process of this era heavily leaned on skilled manual craftsmanship, a labor-intensive endeavor where artisans meticulously crafted intricate details by hand. While the artisanal approach imbued a sense of craftsmanship, it extended construction timelines and introduced the risk of inconsistency in replicated structure. Deviation in craftsmanship could lead to variation between the original design and the replica, adding layer of complexity and unpredictability construction process. Next is laborious and expensive prototyping. Creating physical prototypes in the pre-3D printing era emerged as a laborious and expensive process. Skilled artisans tasked with constructing this model found themselves constrained by the lack of flexibility in the prototyping process. Any alteration to the design necessitates the creation of entirely new physical model, hindering the iterative design process. The associated time and constraint become shackles, constraining the ability to refine and adjust design efficiently, stifling creativity and decelerating the overall development of home design. Next is cumbersome customization. The process of customizing design to suit individual preferences and unique requirements proved to be cumbersome. Each modification demanded a significant investment of time and effort, rendering mass customization impractical. The lack of flexibility restricted architects and homeowners from fully exploring the creative potential of their design, resulting in a more standardized one-size-fits-all approach. The replication process found itself confined by standardized design, limiting personalization to specific client needs. This lack of customization undermined the uniqueness of each home and restricted the creative expression of architects. Next, material limitation. Traditional construction methods impose formidable limitation on material choices and availability, posing a significant challenge in replicating specific architectural features accurately. The inability to easily access certain material hindered the creativity of architects, compelling compromise on design elements. This constraint not only limited the authenticity of replicated structure but also constrained the diversity of material that could be used in construction. Overcoming material constraint emerged as a crucial aspect of improving the fidelity of replicated design and fostering innovation in construction materials. Next was complex scaling challenges. Scaling the size of a house while maintaining design accuracy proved to be a complex task in the absence of advanced technologies. Architects faced formidable challenges in seamlessly replicating design for different plot size or accommodating specific client requirements. This lack of scalability limited the adaptability of design to various contexts, making it difficult to apply design universally. The challenges in scaling hindered the versatility of home design, preventing architects from creating structure that could seamlessly fit into diverse environments and cater to varied needs. And lastly, I would like to talk about the environmental concern. The replication process using traditional construction methods significantly contributed to environmental concern. Material wastage, high energy consumption, and the environmental impact of sourcing and transporting material underscore the inefficiency inherent in the pre-3D printing era. The substantial environmental footprint of construction reflected the industry's struggle to balance the demands for housing with sustainable practice. This environmental impact highlighted the urgency for more sustainable and eco-friendly construction practices. So, as we all can see, the advance of 3D printing technology offers a beacon of hope, promising a future where these challenges are not only addressed but transformed into opportunity for creating homes that are efficient, precise, and harmony with environment. This transformative shift represents a crucial evolution towards a more sustainable and technologically advanced era in home design and construction.
Hi, my name is Nur Fasha Adriana binti Nohaizat and my metric number is AP220019. So now I'm going to explain the product description. 3D construction printing revolutionized building by layering structures with additive manufacturing. It enhances speed, efficiency, and design flexibility through digital design, advanced materials, and precision robotics. The process begins with creating a detailed digital model of the structure using computer-aided design CAD software. This model guides subsequent steps, including slicing it into layers through specialized software. Construction-grade materials like concrete or mortar are chosen for their extrusion and curing properties. A 3D construction printer mounted on a robotic arm follows a precise toolpath to deposit material layer by layer through extrusion or binder jetting. Customizable features include structural reinforcement with elements like reinforcement bars and the ability to embed conduits and voids for utilities during printing. Post-processing involves finishing touches like painting and insulation. Notable advantages include reduced construction time, cost effectiveness, and having no equal design freedom for architects and engineers. 3D construction printing addresses housing shortage, offering a swift and cost-effective solution, especially in crisis-stricken areas. It aligns with sustainability goals by minimizing waste and optimizing material usage. The technology allows tailor-made structures meeting client-specific needs. Thank you.
Next is benefit and disadvantages of 3D printing to the society. In the rapid evaluation of modern technology, 3D printing has emerged as a transformation force, which has the potential to reshape various aspects of society. Benefits of 3D printing to society. The first one is its ability to minimize waste. Traditional manufacturing processes often generate substantial amounts of waste material, as raw material are shaped and molded to create a final product. In contrast, 3D printing operates on an additive principle, layering material precisely to build the desired object. The second one is cost-effective production. Traditional manufacturing methods involve complex tooling processes, which can be time-consuming and expensive. 3D printing eliminates the needs for molds and tooling, allowing for more streamlined and cost-efficient production process. Let's move to the disadvantages of 3D printing to the society. The first one is the potential overuse of plastic. While 3D printing has potential to reduce waste, its reliance on plastic materials, especially non-biodegradable ones, raises concerns about environmental impact. As the demand for 3D printing product increase, so does the consumption of plastic feedstock. The second one is energy efficiency. The technology requires substantial energy to heat and melt the material used in the printing process. High energy consumption not only adds to production costs but also raises questions about the environmental sustainability of 3D printing.
Assalamualaikum warahmatullahi wabarakatuh. In conclusion, 3D printing for house construction represents a revolutionary approach that transforms the traditional building process through advanced technology. This method utilizing specialist concrete construct structure layer by layer offering advantage such as waste reduction and potential cost saving. Proof of concept project demonstrates the precision and efficiency of automate 3D printing in building complete houses. However, 3D printing in building has shown a lot of potential. There are still issues that need to be resolved before it is widely used. To guarantee the security and compliance of 3D print structure, regulatory approval procedure must keep up with this cutting-edge technology, and building rules must be modified accordingly. So, in order to ensure that construction grade materials that are appropriate for 3D printing fulfill the essential structural and safety criteria to continue material research. So, that's all for me. Thank you.